So here in this video, we're going to explore what it's like to actually use Camel99 Fourth, just so you can get a feel for how it operates. It assumes that you will select the editor assembler cartridge, which resets the machine on the Classic99 emulator. We press a key. We select the editor assembler cartridge, which gives us this menu, and we want to run a program file. The program file is called disk1.camel99. So that's running. It loads a few things to add extra commands to the language, which it does by compiling some source code right off the top. Not very much. The first thing I'm going to do is include some programmer's tools, just so you can see what that's like. The file's called tools. Nested within that tools file is the command to compile the case instructions and then to add some deferred words, things that you can learn about later in Fourth. It shows us we've got some low RAM available. You get a sense, if you're used to modern machines, how small this machine really is. We have 7.8K of low memory, which is Camel Fourth treats like a heap. Upper memory, we've got a grand total of almost 15K. And the video display peripheral, VDP, has 10K available. The graphics chip on the TI-99 has 16K of RAM, some of which is used for the screen, for the font descriptions, and also the upper end is used for buffering the file system. So we've got our tools. We'll get a new page by typing the word page. With the tools loaded, we can see what's on the Fourth stack. We can put some numbers on the stack and non-destructively see what they look like, and we can print them off like that. Those of you familiar with Fourth, this is nothing new. You saw how we could include tools. We've also got a few other things, little surprises, like we can load a directory utility. Now the first thing the directory utility needs is file support. Camel Fourth has a ANS file system that lets you have handle-based files, like you would see in DOS or even Unix, which we've added on top of the file system for the TI-99. So this gives us access to the standard Fourth words like open file, read file, write file, things like that. Now it did take a whole 1.4 kilobytes of RAM to have that facility, but there it is. We can also see all the keywords that are in the language at the moment. It's quite a laundry list. Fourth is rather verbose that way. You'll notice that it's telling us we have 19A words. That's because it wakes up in hexadecimal math. If you prefer decimal, just type decimal. We'll do that operation again, and you can see that decimal numbers will be printed out. We have 410 words in the language at the moment. We have a directory utility now, and we can see what's on disk 1. And there's 127 files there. We can do, this particular emulator has 4 disk drives. We've got some stuff out there on disk 4. We can look at disk 2. It's got some fonts and a few other demonstration programs. So that's how the directory utility looks. What else do we have? Get a new page. We can take a look at, we can include a more utility. More allows you to see the contents of a file. Now, more uses the ANS files system as well, but because it's already loaded, more conditionally knows to check to see if the ANS file system has been loaded and doesn't try to recompile it again. So it only took 24 lines of code. So let's see what it looks like. We can go more, disk1.more, and actually see the source code. that the more utility compiled. If you understand forth, that makes some sense. The key thing to look at is at the top line. You can see this is a non-standard forth extension that I've added to Camel Forth because it's small. Standard forth has conditional compilation controls, if, else, and then, but they take quite a bit of real estate on a little computer. So I've changed it to use these two simple words, needs and from. And you can say, this program says it needs open file from disk1.ans files. The needs word simply looks for the word you're asking it to check for in the Forth dictionary of words that we just saw. And from will include that file name if there is a true flag returned from needs. It's that simple. It's literally variations of the fourth word find and the fourth word include. So that's what it took to program the more utility. You can see one of the disadvantages of the TI-99 is the 40-column display. However, that's better than the 32-column display one gets in TI Basic, but it still is not very nice for displaying 80-column text files. Currently, Camel99 Forth does not have its own editor. I'll show you what we have to do to use the editor. We have a copy of the TI-99 editor loaded on the disk, so we can say edit is 1. Let's load a file, and let's look at that more utility again. And now we press 2 to edit, and here's the more utility in the editor. This is a 40-column editor, but it has the ability to scroll to the left in rather abrupt chunks. Future versions of Camel99 Forth will have a loadable editor. It's under development right at the moment, and we will get there. Now, unfortunately, we had to leave Camel Forth, and so in order to use that file that we just edited, we have to pop back to here and restart Camel99 Forth, which is relatively quick, but still. So let's say we had edited the more utility, and now we would include it. And of course, it determined it doesn't have the file system, so it compiles the file system first. So this gives you a sense of what it's like to operate Camel99 Forth in the real world. While I'm sitting here, I can show you that we have the ability to dump different sections of memory for debugging purposes. Let's see what we can do here. We can go, let's look at where Forth resides. We will dump hex at hex A000. We'll dump hex 100 bytes, which is actually 256 bytes. So there we can see the contents of the binary part of the Forth kernel. We also have something called VDump, so we can look at literally the video screen. Let's look at what's on the video screen at the moment. Here's VDump, and we can see that we're dumping the contents of our own dump, because we're putting things on the screen and we're reviewing them back. That's a little confusing. Let's just for fun look at address 1000 vdump. This is in the video RAM, and we can see there's nothing there. Very little there. What else can we do? I think that's probably enough for now. That gives you a sense of what it's like to use Camel99 Forth. Put the directory back, and we'll look and see if there's anything we want to look at here. Let's try this one. C. We don't have C. I typed it in wrong. disk1.c. This will take a little while to compile. This is actually a fourth decompiler, which lets us look at, well, it didn't take that long. Let's take a look at C.S. And there is .s decompiled. What happens if we try to decompile, oh, I don't know, dot? Wow. Took quite a bit to do that, but it showed us what's involved in decompiling dot. Let's decompile C. That's the actual code that was compiled to make the decompiler. So you can see we've got a few utilities with this system. It allows you to do things that are pretty fun and fancy for the TI-99. We'll show some other demonstrations in another video, which we hope to publish soon. Thanks for watching.